Dominique Linkhammer and I were at a meeting earlier this morning to talk about the application of hydrodynamic cavitation oxidation to knock down harmful algal blooms, basically at their onset. So this is a day that I'm really focused on harmful algal blooms. Just to start, we have a very significant problem, as you all know. And I know it affects me very much, it affects my family very much. To be able to tell 9 grandchildren that they can't go in the water is something very difficult to do. And so I think particularly with Giorgos' expertise in the area of remote sensing, I think we're right on the threshold of developing a tool that will be extraordinary in terms of monitoring the potential development of harmful algal blooms. These are basically the characters. This is microcystin LR, large molecule on molecular weight of 995, 7 amino acids. And then you can see the structure basically of the cyanobacteria. Cyanobacteria has been around for millions of years. We owe the oxygen envelope that we currently have to cyanobacteria. And right now, cyanobacteria are not serving us very well. We talked through Dave's presentation, particularly with several streams going in Skaneateles Lake with fairly high nutrient levels, largely reflecting agriculture runoff, but obviously we have the land uses, for example, on homes and lawns and those kinds of things also creating a problem. As many of us feel, legacy sediments may be playing a very important role. Now, big thing, and I'm very fortunate to be around Greg Boyer, who is has extraordinary expertise in the area of neurotoxins and renal toxins produced basically by microcystin and toxin from the cyanobacteria. But it is creating a big problem. It's having a very severe negative impact on the water resources. A lot of times we don't think about what the monetary impact of that is. It has a major monetary impact. If you look at tourism in the Finger Lakes, a $3 billion a year industry supporting some 58,000 jobs. HABs prevalent in the summer threatens basically the peak of the tourist industry. These economic threats also extend to the requirement for new infrastructure, whether it's in the case of the city of Auburn, looking at nanofiltration possibly being needed to address the issue of toxins liberated from cyanobacteria, to the city of Syracuse, where its filtration waiver is potentially at risk. That, I think, in terms of $100 million in capital investment for a water treatment plant for the city of Syracuse, it's probably more like 150. And a big thing is real estate values. And I think we've seen around Skaneateles Lake a strong interest on the part of those who have property on the lake to preserve the value of their assets through the contribution of funds to the Skaneateles Lake Association to pursue solutions to this problem. And basically, harmful algal blooms are here to stay. In fact, they're going to get more intense. New York State classically has 100 to 125 lakes for which harmful algal blooms are detected, and it's becoming an increasing problem. With that, my colleague Giorgos Mountrakis is working on developing a system that will help us in detection, monitoring, and long-term prediction. Giorgos?
Thank you, Neil, and thank you for the invitation. Today I'm going to discuss mostly phase 1, but I wanted to put over there the long-term goal that we have eventually to not just monitor, but have the capability to predict where those blooms will occur. So the topic that I'm interested in is how you can use remotely sensed imagery to initially detect and monitor the condition of the blooms in the lakes. And there are several layers that we can use for this detection process. There at the very top we have the satellites. Then if you look into lower altitude, we can fly airplanes, and now with the proliferation of unmanned aerial vehicles, also known as drones, we can have really efficient and effective monitoring across a much larger area than we could before. So here's some examples of what satellite technology can do. This is a satellite, this is called Landsat. Each pixel size on the ground is about 30 by 30 meters. And you can see an image here from the Skaneateles lake taken fairly close to when the big HAB incident took place in September 2017. You can see here the view from an airplane as well, close to those days. The major advantage of this type of satellite is that it's freely available. We can access it, we don't have to pay any royalty fees, we just connect to the NASA servers and we can get the data. One of the limitations of this satellite is the pixel size. It's about 30 meters, so there has to be already an ongoing substantial bloom to be able to be detected. The other limitation is that it flies around. There are two of these satellites, so we will get data every week. So it's not a daily type of monitoring exercise. We are also partnering with a private company. It's called Planet Labs, and they have satellites that they can cover an area on the ground on a daily basis. And their capabilities are much stronger in terms of both revisiting time, daily data, but also in terms of the pixel size. And the pixel size being much smaller, 3 to 4 meters, that allows us to detect a much smaller bloom at the very early stages. Now, I should mention that this is a commercial company, so there is a potentially high dollar figure associated with acquiring these images. So what we are thinking is using a multi-scale approach where you can have the free satellites giving us some warning signs, and then whenever we see there is trouble or potential for trouble, we go into more expensive solutions. The middle of the road in terms of expenses, or before I get there, here's another image where we can use radar satellites to give us the information. The major benefit of radar is that it can see through clouds. So if you are a native or you've been within central New York for a while, you know that clouds is an issue, right? So the first satellite does not go through clouds. This one does. So with specific analytical tools that we have in our lab, we can analyze them and detect the bloom occurrence. And this is just preliminary data that I'm putting for you up there. Obviously, once we start applying our computational algorithms, we can get much more accurate results. Now, if we look now into phase 2, one of the advantages that we have with the satellites is that we can go back in time. So if we could develop a system that can detect the blooms right now, there's nothing stopping us to running them back and detect the blooms 10, 20, even 30 years from now, in the past. And by creating this historical record, now we have the capability to take that historical record of where the HABs were in the past to create a much more dense modeling record that can help us identify short-term warning potential of this data set. So we can take the historical HAB data, where it took place. We have other satellite data that we can incorporate in that relate to either land use, maybe the topography close to the lakes, temperature data, precipitation data, and we can marry that with other field-based data like weather stations, and eventually fit that into a model that can allow us to have a fairly accurate short-term probability of occurrence. And by short-term, maybe think of it maybe a week ahead of time. So this is the phase 2 of what we're proposing, which is obviously dependent on having those historical data from the satellites from phase 1. The holy grail of where we want to go. Now, if you look long-term, and long-term meaning how would the lake look like 10, 20, 30 years from now? What we can do is, once we have this model developed, then we can use, again, satellite data that we have that are fairly static. They don't change so much. They're not as dynamic. And then we can replace the temperature, the precipitation data that we have from the current conditions with future conditions based on global circulation models, on how the temperature will be 20 years from now, 30 years from now, 50 years from now. And then by that, we can have the probability of HAB occurrence much longer term in the future. So this is not necessarily a short-term prediction, but it can help managers and maybe get the attention, not just for Skaneateles Lake, but over the entire New York State or the county as well. So to summarize the capabilities, we start with the data, which is an integration of both satellite data and field work. We create that with actionable to actionable information. So in the short term, what is happening right now. Then we can go into knowledge discovery by merging all these data sets to a short-term prediction after we understand the drivers. And then eventually, in terms of future mitigation and adaptation, if we cannot necessarily go to the mitigation route, what the lakes may look like long-term in the future. And with that, I think Neil and I would be happy to answer any questions you may have. This is a presentation I shared with the Department of Environmental Conservation. So we're in the process now of seeking funding from their side to undertake those tasks. I know we have a few DC representatives, so I'll be happy to make a more specific selling pitch. Maybe all of you can